Okay, hello. Happy Wednesday, guys. This is our August week 3. Okay, how are you guys doing? Okay, August week 3. And before I begin, sorry, my light here today is a bit weird because there's a spotlight on top of my head. I'm in another room, so I'm gonna look weird today. Okay, hi Jenny, how are you? Haven't seen you in a while. How are you doing? Okay. Yeah, guys, before I begin, there's a quick announcement. Next week will be a holiday. All right, I believe some of you already know, but just a reminder, right? That means next week's class is still as usual. Okay, next week still as usual, but the following week is gonna be a holiday. Right? So next week is August week 4. The following week is a holiday. Then the coming week, it's gonna be September week 1. Okay, guys, we are not skipping a week. It's an extra week that we are taking off. So please take note. All right. So, guys, can you see me? Can you see me? I look a bit weird today because there's a this room's light is a bit weird lah. Okay, so we hope you can see me. All right, so guys, we were in chapter 8, right? Okay. So Jenny, have you watched the video I sent you? You missed last week, right? If I'm not mistaken. Did you watch the video I sent you? I hope you did. Okay, good, good. So today we are going into isotope today. Okay, 8.3. Guys, are you ready to learn? Are you ready to learn? This is gonna be a easy lesson today because what's remaining now, it's not something hard. It's easy. All right. So if you're ready, then let us begin. Right. So what is an isotope? Okay, before I talk about isotope, okay, there's a reminder here. Please take note that nucleon number equals to proton plus neutron. Do you remember this? Do you remember this? Nucleon is the nucleus, right? Proton is the positive one. Neutron is the no charge one. We learned this like many weeks ago. Last week I mentioned it. Last week I mentioned it. I keep mentioning it for many times. Do you remember? Do you remember? I hope you do. Okay. So this is our isotope. Okay, sorry. This is our nuclear number. Okay, guys, for simplicity's sake, okay, I know you guys are kids. Okay, you guys are kids. You guys are kids to me. Right, I'm going to refer it as proton color as the blue ball, proton color as the blue ball, neutron as the yellow ball. Right? To get the total number, which is the nuclear number, you add the blue ball and the yellow ball. Am I making sense here? Am I making sense here? Because you see, we are all visual animals. Okay, only when I do it this way, you can understand. Okay, so proton is the blue ball, neutron is the yellow ball. Can see Can see Can see Can see so nucleon is the total. Nucleon is the total. Okay, this is the first thing I want you to take note. Right? You might forget it from last week, but I don't get. Okay, this week you must remember. Okay, so what is an isotope? What is an isotope? Okay, isotope are atoms of the same element with the same number of proton, but different number of neutron. Okay, so let me explain. Do you remember what is number of proton? Do you remember what is proton number? I did say before, proton number is the ID number, isn't it? Proton number is the ID number. For example, ID number 1 is like IC number. You see, ID number 1 is for sure hydrogen. Okay, ID number 1 is for sure hydrogen. There will be no one else with number 1, right? But somehow, you see, there's a weird case here. You see, there's a weird case here. There are 3 hydrogens here, right? They are like clones. You know, clone. If I clone you, there will be another you that looks exactly like you. Okay, you guys have the same IC. Weird, right? So same thing here. So hydrogen, they have the same proton number because they have the same IC. They have the same IC. But somehow, right, their neutron is different, which is the yellow color ball different, right? The yellow color ball different. Or you can say nucleon number lah, because when the yellow color ball is different, the nucleon also different. Okay, can you see this number? Okay, since we know proton plus neutron is nucleon, isn't it? Okay, so 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3. So usually the number behind this is the nucleon number. Guys, are you following so far? Are you with me? Are you following? Are you following? Do you understand this? Yes, yes, so this is the nucleon number, the total number, which is the blue color ball with the yellow color ball. Okay, so this is the blue color ball. This is the yellow color ball. Now you understand. Okay, you see, I have to use the ball color one. If not, you don't understand. Okay, so electron you can don't care because, like I said, electron and proton is always the same. Remember when we draw the circle thing last week? This one, how many proton means how many electron. So electron you can ignore. Okay, we don't care, right? So the isotope, they are the same proton number because they're the same guy, same IC number, but they have different neutron number. Okay, so you have hydrogen 1, hydrogen 2, and hydrogen 3. Like you see carbon, you have carbon 12, carbon 30, and carbon 14. Right? You see, they are all same IC number. All number 6. Because you go back to periodic table, number 6 is carbon. You see? 1, 2, 3, 4, 5, 6. Carbon is 6. Right? So all 6 here. All 6 here. 3 also 6. Okay, electron don't care. And then neutron is 6, 7, 8. So 6 plus 6, 12. 6 plus 7, 13. 6 plus 8, 14. Okay, you must say, sir, how come there's no carbon 11? How come there's no carbon 15? This is nature. This is nature. Like you see oxygen, like you see oxygen, they are both IC number 8. Okay, so 8 plus 8, 16, 8 plus 10, 18. Hey, sir, where's oxygen 17? Where's oxygen 17? There's no oxygen 17. Okay, for some reason, okay, don't ask me why. That's the way it is, right? It's asking, sir, why do you have 2 hands? Because it's not 3. Yes, yes, I know the answer sounds stupid, but that's the way it is, right? So this is the way it is. Okay, right, guys, are you okay so far? This is basic maths, guys. I'm serious. This is basic maths. Okay, we go to the bottom one, you understand. Okay, so let's see chlorine 35 and chlorine 37. Remember what's the 35 and 37? Guys, what's the 35 and 37? What does it represent? What is this number? What is this number? Is it proton, neutron, or nucleon? Which is it? Guys, let me test you. Which one is it? Proton, neutron, or nucleon? It's mentioned here. Nucleon, right? Very good. Okay, so you see 37, 37. So 35, 35 lor. Okay, so 23, 24, 23, 24. 79, 81, 79, 81. You fill up first. Okay, that's the nucleon number. This is the nucleon number. Okay, now proton, neutron, nucleon. We know that proton plus neutron is the nucleon. Correct? Correct? Proton, neutron, nucleon. So I put it this way, you understand. Again, yellow, sorry, blue color ball. Oh shit, this background is yellow. How? Okay, I change orange, okay? Yellow ball. Okay, yellow ball. So you see, blue ball, yellow ball, total ball. Okay, so now they tell you there's 18 yellow ball here. And then there's 35 total. So what's the proton here? So what's the proton here? Guys, what's the number here? How do you get this number? How do you get this number? Guys, how do you get this number? Basic maths, hello. What is this number? Can anyone tell me what is this number? Hey, you guys still there? You guys still there? What plus 18 is 35? Guys, what plus 18 is 35? Oi, hello. Is everyone here? Is anyone here? 17, thank you. Okay. Jenny, are you there? Just checking on you. You're dying. Why? School, is it? You're always dying on Wednesday, huh? It's so unfortunate, isn't it, that your Coco and my class just sort of clash. Okay. What do you mean? Is that a typo? Okay, so guys, what about here? What about these two then? What about these two number? Can someone tell me? What about these two number? What about these two number? What should we fill in here? 17, 20. Very good. Why is it 17? Because they belong to the same person. They have the same IC. Remember? 17, 17. So proton is the same. Okay. So 17 plus 20 is 37. Okay. Jenny, I'm not doing something heavy today. I hope you can follow along because I really want to do something easy today, which is unfortunate because next week we are going into a new chapter right before the holiday. You see, I hate teaching new stuff before the holiday because chances are you will forget everything when you come back. I know. Okay, I know. Right? So Jenny, you have to fix this. I mean, if you come to class like tired every Wednesday, it's gonna be hard for your learning. Okay, hope you can do something about it if you can lah. Okay, so guys, what about here? The same thing, 11, 11, same IC number. Okay, what about bromine? It's going to be 35, 35. Same IC number as well, because both are bromine, 35, both are sodium, 11. So I think you can fill in the remaining ones. Okay, so 11 plus 12, you get 23. 35 plus 79 minus 35, so this is 44. Okay, and then 35 plus 46, you get 81. Okay, do you understand this? Do you understand this? Do you understand this box here? Can you understand every number? My point is for you to understand every number here. It's nothing difficult, guys. It's nothing difficult. It's just basic maths, basic addition and basic addition and subtraction. Okay. Easy stuff, easy stuff. I'm not doing serious things today. Hey, by the way, guys, this isotope, right? It's for sure coming out for exam. Right? Isn't it good? Isn't it a good thing because it's 3 marks for you? Okay, it's a good thing. Right? So anyway, let's go to our use, shall we? Okay, this is the last part, guys. Give me 5 more minutes of attention. Can you? Can you give me 5 more minutes of attention? I mean, later we'll do exercise lah. Okay, this is the last already. All right, guys, you might say, sir, we learn isotope for what? We learn isotope for what? Guys, there are a few isotopes, okay? And we call them radioisotope. What does it mean by radioisotope? Radio means radioactive. As in got radiation. 辐射. Okay, 辐射, radiation. Okay, guys, I'm not talking about lame radiation like Wi-Fi. Yes, Wi-Fi is a radiation, but it's not a bad or dangerous radiation. I'm talking about dangerous radiation like gamma, alpha, beta. You remember from last year? Do you remember alpha, beta, gamma from last year? That's what I mean by dangerous radiation. Okay, so that's the meaning of dangerous radiation. So anyway, guys, hang on, my laptop's running out of battery. Let me unplug this real quick. Okay, so let's talk about radioisotope. Okay, these isotopes, they are radioactive, but they are very useful to mankind. Okay, let's look at the first one, sodium-24. Okay, this one you must know. They will ask this in exam. Okay, what is sodium-24 for? They are a very good tracer. Okay, they are a very good tracer. Do you know what is a tracer? Do you know what is a tracer? Do you know what's the meaning of a tracer? Okay, let's say now I'm a stalker. I want to stalk you. So what do? I put a GPS tracer in your car. You know what I mean? I take a magnet GPS, I stick to your car. So the thing will trace your way back home. I will know where you live. So that's the meaning of a tracer, right? 追踪器 tracer, right? So sodium-24 is also a tracer. We use it to trace what? To trace any pipe. You know what's a pipe? 水喉, okay, pipe. Okay, so sodium-24, okay, if you want, please add one more here. It is used to detect underground pipe leakage. Okay, underground pipe leakage. Okay, what does it mean? What does it mean? Let's say now you have a pipe underground. Okay, this is a pipe underground. So this is the main ground here. Okay, let's say now there's a leakage here. There's a place here that breaks, and then there's a leakage coming out here. But you don't know where is it. Okay, let's say this pipe is 100 kilometers. Let's say lah. Okay, let's say okay, you know there's a leakage somewhere. So what do? Do you dig up all the soil up and you find where's the leakage? You get what I mean? Hey, 100 kilometers is not near, you know. I dig up all the soil, I dig up everything, and then I find where's the leakage. Is it okay? Do you think it's smart? I mean, we can do it lah, but do you think it's smart? Not really, isn't it? It's a very stupid way to find a small leak just by digging up 100 kilometers of soil, right? So instead of doing this, why not we put sodium-24? Okay, we put sodium-24. Since this thing is radioactive, right? Since this thing is radioactive, whatever, okay, let's say there's a leakage here. The sodium-24 will leak out here. And this part of the soil will be radioactive. If I put a radioactive detector here, okay, if I put a radioactive detector here, oh, this part is radioactive, that means there's a leakage. Can understand? I'm using this to trace the leakage. Tracer. That's why it's a tracer. Sodium-24 is a tracer. 追踪器，拿来追踪哪里有漏。Okay, we used to chase where the leak is. You understand what I mean here, guys? Do you understand what I mean? So sodium-24 is a tracer. We have to know where the leakage is. Okay, where the pipe leakage is. Okay, but in medical, right? We use it to detect blood clot. Same as a tracer. You see, our blood vessel, okay, our arteries and our veins, they are a lot like pipes. Think about it. Can you see your blood vessel? Can you see my blood vessel right now? You cannot, right? It is underground too. It is buried inside me. So I can use sodium-24 to detect where a blood clot is or where the internal bleeding is. You know what's internal bleeding? Okay, to detect where the internal bleeding is, to detect where the blood clot is. Right? If let's say you're having a heart attack, I can use sodium-24, I inject into your blood vessel, and then I will put you into a MRI machine to find out which part has radiation. Then I know which part of the blood vessel is stuck. There's a clot there. Do you understand, guys? Do you understand? Are you following me? Are you following me? Guys, it's a very simple thing to learn here. Okay, yes, yes, okay, let me tell you a few more tracers. Okay, iodine-131 is also another tracer. Phosphorus 32 is also another tracer. Okay, these three are tracers. Like iodine 131 is to trace thyroid disease. You remember what is thyroid? We learned this like last chapter. You know, thyroid, this thing controls your metabolism, remember? If you want to find out what's wrong with this, we use iodine 131. This thing is also radioactive. Okay, phosphorus 32, this is for plant, because plants, they absorb fertilizer. Fertilizer is made from phosphate. Okay, phosphate or phosphorus is the same thing. So I want to know how good a plant absorbs fertilizer. I will give them this thing. If the whole plant becomes radioactive, means the plant is absorbing phosphorus very well. Also another tracer. Can? Do you understand what is a tracer now? I am following where the blood clot is. I am following your thyroid. I am following the fertilizer. I follow, see whether they are doing it well. Tracer lor, like your GPS tracer lor. Like I follow you home lor. Okay, these three quite important. And of course, you have cobalt 60. Cobalt 60, they will produce gamma ray. Do you remember what is gamma ray from last year? Gamma ray is the strongest electromagnetic wave, strongest radiation. So we use this to kill cancer cell. Okay, gamma ray is very dangerous. It will kill everything. So we use this to kill cancer cell, right? Or we call it radiotherapy. You know what is radiotherapy? You know what is radiotherapy? In Mandarin, we say 电疗. If you understand that. Okay, you see, when you get cancer, normally when you hear people get cancer, they will get two treatments. They will get radiotherapy and chemotherapy. You know, it's chemotherapy, 化疗. This is when they hang a bag of chemical and drip it into your body so that they can kill the cancer cell. Right? So cobalt 60 is for radio. Okay, and not only they can kill cancer cell, they can also use to kill bacteria. Okay, kill bacteria. Usually we do this for exporting fruits. Okay, let's say Japan, they want to export their strawberries, and strawberries, they spoil very quickly. So to make the strawberry last longer, they will bombard it. They will they will use cobalt 60 and kill the bacteria before they export it. I mean, yeah, sure, it's not going to last much longer, but it will last like 1 or 2 weeks more. So that's enough, lor. Better than nothing, lor. Okay, better than nothing, lor. At least the thing can last. Okay, so cobalt 60, we use it to kill cancer cell or to kill bacteria. Next, carbon 14. I don't want you to remember this carbon 14. I want you to remember this carbon 14. Okay, carbon 14 is to determine the age of fossil. What is a fossil? If I get something from the ground, right? Have you ever wondered why? Have you ever wondered why they say, oh, we just found a new T-Rex bone. It's 20 million years old. Right? And then you're there sitting there thinking, how do they know? The bones there got right, man? No, okay, because they scan for the carbon 14, right? So carbon 14 will tell you how old the fossil is. So then you can piece together the history of, okay, what comes before what, okay, which animal comes before which animal. So they will use carbon 14 because no one was there to record it, but carbon 14 was there to tell the story, who was there first. Okay, right? And then americium, this one don't care. Uranium 235. If you watch Oppenheimer, the movie, they did say this. This is to use it for nuclear power station or for nuclear bomb. Okay, the bomb dropped on Hiroshima, I think. That's the uranium 235 bomb. Okay, the one in Nagasaki, if I'm not mistaken, is plutonium. So this is one of the way to make bombs. Okay, guys, this is all those highlighted ones. What I want you to memorize. I mean, it's almost all but it's not that hard, right? If you do more exercise, then I'm sure it'll be in your head already. Okay, so everyone, so far so good. So far so good. I know this is a bit boring, okay, to say the least. But hey, it's gonna be easy at least. It's going to be easy, right? So today's take-home point is this: nucleon, proton, neutron, and this, and this. That's the three things you need to know. Okay, huh? Okay, huh? If you're okay, then I'm going to proceed, huh? All right? If you're okay, I'm going to proceed, huh? Okay, so let's go to our exercise, shall we? Let's go to our exercise. I will try to finish this as fast as I can. Okay, guys, can we please go to question 13, page 12, question 13. Okay, so I know your book looks a bit black here, but here comes the light gray color is neutron, the white color is proton. So there are two neutrons here, two protons here, one neutron, two proton, one neutron, one proton. Okay, are you ready? This way you won't get confused, because the exercise in the notes you get is a bit black. Okay, so A, name two subatomic particles in the nucleus. What is subatom? Okay, this one many students they don't know. What is subatomic particles? Subatomic particles are these three lah. The proton, neutron, and electron. So which two is in the nucleus? What is in the nucleus? What is in the nucleus? You have electrons spinning around outside the nucleus. So what's in the nucleus? What's in the nucleus? That's the nucleon, which is proton and neutron. Okay, do not get this wrong, guys. Do not, I repeat, do not get this wrong. Nucleon number is proton number plus neutron number. Huh? Understand, Do not get this wrong, please, Okay, so B, which atom is positively charged? Okay, so there are three atoms here. Which is positively charged? This one, you have to look at it, Okay, can you see this one got two just look at the proton and the electron. We have to look at how many plus, how many minus, right? So we have two protons here. So 2 plus. Two electrons here. 2 minus. So guys, I have a question here. If I have 2 plus and 2 minus, what's my overall charge? What's my overall? I have 2 positive and 2 negative. What is my overall? Anyone? What is my overall? 2 plus, 2 negative. Positive 2 and negative 2. What's the overall? No one? Guys, basic maths. Basic maths. 2 plus and 2 negative. What do I get? What do I become? Zero. Good. So we can say this guy is neutral. Right? I have no charge. Right? So what about this? What about this? I have 2 proton, 1 electron. What's my overall? Yes, it's a 1 positive. Okay. What about this? 1 proton, 2 electron. Now what's my overall? What's my overall? I have 1 positive and 2 negatives. So what's my overall? Jenny, what's the overall? What's the overall? -1. Good. Okay, so there comes. That's our question, which is positively charged? This guy, P. Which is negatively charged? This guy, M. Which is neutral? This guy, R. Sorry, S. Can? What is nucleon number? Do you need me to say this? Do you need me to repeat this? What is nucleon number? You don't, You don't, huh? You don't, right? Nucleon is proton plus neutron. I don't want to repeat this like a broken record. Okay, so state the nucleon number for S, P, and M. Okay, what's the nucleon number here? What's the nucleon number here? Guys, nucleon number here? Nucleon is proton plus neutron, right? So what's the nucleon number here? Neutron plus proton. What's the number? What's the number? You have 1, 2, 3, 4, right? So nucleon number 4. Okay. Guys, I need some response here. Thank you. What about P and M? What about P and M? Hey guys, this question is coming out like in exam. Your exam question is going to look something like this. I'm not lying to you. Okay, so there is no reason for you not to score here. 3 and 2, thank you. Okay, but of course, I don't think your teacher is going to give it so many marks here. You see, this is like 2, 3, which is 5, 5 plus 1, 6, 6 plus 3, 9. Okay, do you think you get 9 marks like that? I don't think so. Yes, you're good. Okay, so let's look at 14, shall we? Let's look at 14, shall we? Okay, usually when you look at periodic table, you look at every element, there will be 2 numbers. Guys, can you tell me which number is what? Okay, let's look at the bigger number first, shall we? What do you think the bigger number is? What do you think the bigger number is? Right, I'll give you a hint. Since the bigger number is bigger, right? It's a total number. What total number is that? What total number is that? Can anyone tell me? What total number is that? Is it the proton or the neutron or the nucleon? Guys, give me a moment. Okay, so here comes. Right, Jenny, is proton the total? Is proton the total? Proton plus neutron is what number? Am I making sense here? Am I making sense here? So proton number is that 2. Okay, this bigger number is usually the nucleon. Can because nucleon must be bigger because it's the total. You see, yellow color ball plus yellow ball and blue ball, it must be a bigger number, isn't it? So that bigger number is for sure nucleon. Okay, and why show proton? Why not neutron? Because proton is the IC, right? Neutron has no meaning one, but the IC has meaning. That's why proton is shown so that I can arrange my periodic table. You see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's why the 2 numbers, 1 is the nucleon, 1 is the proton. So how do I get neutron? You minus law, right? Because neutron is not that important, so they don't show. Okay, they don't show. Hey, sometimes they will do it this way. Sometimes they will put 35, 17 like that. No matter whether they put up, down, up, the meaning is the same. Okay, so what is the nucleon number again? You need me to write this? You need me to write what is nucleon number? You don't write. Okay, good. Okay, write the electron arrangement for X and Y. How do you think X arrange their electron? What is electron arrangement? This is the one we learned last week, 2, 2.8, 2.8.8, 2.8.1, 2.8.3 are those. Okay, how do you think X do it? How do you think X does it? Okay, first you have to tell me, guys, X has how many electrons? Okay, X has how many electrons? So now how do you get 2.4? Okay, electron is equal to the proton, right? Electron is equal to the proton, right? Okay, so proton law. So if I have 2 electrons, how am I arranged? How am I arranged if I have 2 electrons? Just 2? Yes, Zhentong, you are correct. Just 2. There's no point something because that's the only they have 2. So X is a very, very happy atom because X is stable already, ma. Remember what is this called? If my first shell is full, there's a word for it. What do we call? We call it duplet. Remember? Remember what is duplet? 8, we call it octet. Yes? You remember that? So X is already duplet. He's a very happy guy. He won't do anything anymore. Okay, what about Y? How do you think Y is arranged? How do you think Y is arranged? 2.8.6. Very good. Okay, from that 16, right? 2.8.6. Cool. Okay, good. So C, state the number of electrons present in the atom of element X. Okay, how do you think, how many electrons do you think X has? X has how many electrons? X has 2 protons. So how many electrons? How many electrons? 2 law. Yes, correct. Explain. Why do you think it has 2 electrons? Because it has the same number of proton and electron. Okay, same number of proton and electron. Can I? Can I? Okay, easy, easy. Okay, so D, state the number of neutron in Y. How many neutron do you think this guy has? And how do you get the number? You have nucleon number there, you have proton number there. So how do you get the neutron? Do you understand what I mean? Do you understand what I mean? I have the nucleon there, I have the proton there. So how do I get the neutron? Guys, I have the total, I have the blue ball. How do I get the yellow ball? How do I get the yellow ball? Guys, this is primary school mathematics. Yes, 32 minus 16. Yes, that's good. Okay. And you need to show the working because they want you to explain. You explain it by showing the working. Yes, not very good. That's the answer I want. Okay, so E, which atom will form an ion? Explain the formation of this ion. Okay, which one will form ion? Which atom here do you think is very unhappy? Okay, we know that X is, okay, let me erase this first. Okay, we know that X is 2, right? Y is 2.8.6, right? What about Z? What about Z? How is it arranged? How is this guy arranged? Yes, good, 2.8.7. So who's the unhappy here? There's actually 2 guys unhappy here. Who's the unhappy one? And what will they do? Who's very unhappy here? Who's thinking that, wow, why am I not full? Like I said just now, X is happy, right? Because this guy says, yeah, I already got everything. I don't need anything anymore. Okay, so who's the unhappy one? You have Y being unhappy because she wants 2 more. You have Z being even more unhappy. She needs 1 more. Right? So what will Y do? Y will take 2 electrons, correct? Y will take 2 electrons. So once my Y took 2 electrons, what will the arrangement be? Y is 2.8.6, right? I take 2 more, I become? Guys, what do I become when I take 2 more? If I am Y, I take 2 more. What do I become? How am I arranged now? From 286 to what? Okay, from 286. They wanted to draw. This is what we drew last week, right? From 286 to, okay, now I'm 286. Can you see? I'm 286. So I take 2 more. What will I become? I will become 288, right? My job is to become 288. Guys, do you understand? Do you understand? Can you make my job a bit easier here? Please say you do. Yes, okay. So once I take 2 more, what do I become? What's missing here? The one we drew last week. What's missing here? How do I show people I took 2 electrons? What's missing here? Hello, guys, what is missing here? Hello, what is missing here? What is missing here? Guys, what is missing here? Last week we drew, how do we show people we have 2 electrons? I need the square bracket and I need 2 minus. Correct? 2 minus shows people, yes, it's not good. Okay, 2 minus means I took 2 electrons. Do you understand? Yes? Guys, do you understand? Make my job a bit easier here. Okay, so 2 minus 2 minus Jenny, you okay? Okay, good. Okay, what about Z? Okay, there's 2 answers here. There's 2 answers here. What about Z? Z will take 1 more, right? So Z, okay, Z is 287, right? What will it become? Guys, we have a few more questions to do. Can you please, we need to speed this up. So what will it become? I have so many things I want to cover. Okay, from 287, what will it become? Come on, guys, don't be lazy. Think. From 287 to what? How do I become happy? How do I become full? 288, good. Okay, 2.8.8. Okay, so what's missing here? What's missing and what's the charge? When I take 1 electron, what do I become? When I take 1 electron, what do I become? Hello? Hello? Hey, I'm very good already. I write answer for you. You know, if you go teacher his class, he will never write the answer. You're writing it yourself, and he's asking you, he will ask you to answer in front of like what 40 students. So you see now our class is very small already. You don't need to be shy, and I'm writing the answer for you, right? So a little bit cooperation would be nice, guys. Okay, what's missing here, guys? What's missing here? We have so many questions to cover. What's missing here? Hello, what's missing here? Yes, thank you. Square bracket and a minus here, right? We don't write 1 minus, we don't write 1 minus because in chemistry, we don't write 1. Okay, in chemistry, we don't write 1. Are you following? Are you following? Jenny, is it lazy? Is it you being lazy to type or you don't know the answer? Just checking with you. Do you know the answer, or you're just lazy to type, or you really don't know? Huh? Really don't know? Huh? Why don't know? You learned this? Wait, were you here last week? You weren't here last week. No wonder. Okay, go and watch my video last week, then you'll understand. Okay, guys, let's go to question 17. Let's go to question 17. This is page 15. Wow, guys, we have 10 more minutes. I have so many to cover. Right, so you have element X, Y, Z here. You have proton number. You have nucleon number. Okay, again, nucleon is the total. Proton is the blue ball. Okay, so determine the number of neutron. Neutron is what ball? Neutron is what ball? And how do you get it? Guys, neutron is what ball? What color ball? Is it have to use the color to make you understand? Okay, neutron is what color? Yes, yellow. Thank you. So how do you get it? How do you get the number? How do you get neutron? How do you get neutron? You take the total. Jenny, I believe you can. You know this, right? Do you? Do you? You take the total. What do you do? This is blue plus yellow ball. What do? You have to minus off the blue ball to get the yellow ball. Okay? Guys, this is primary school level mathematics. Okay, so 27 minus 13, you should get 14 here, 18, and 20. 14 yellow ball plus 13 blue ball, it will be 27 balls. Okay, I think this is something that a 5-year-old will understand, right? I'm not saying you're a 5-year-old, but close to it. Okay, so how will X, Y, and Z arrange? What do we look at? Do we look at the neutron, the proton, or the nucleon? Guys, I can't believe this is the nth time I've repeated this. Okay, proton, yes. So how is this arranged? How is X arranged? How is X arranged? 13 is how? I'm just gonna write it here. I'll write it here lah. Okay, yes, 2.8.3. Guys, please draw this yourself. I'm not gonna draw. I'm just lazy. Okay, what about this two? 17 is how? 17 is how? 2.8.7. Good. What about 20? What about 20? 2.8 point. 2.8 point. What's next? Guys, come on, speed it up. We have so many questions to cover. 2.8 point what? Hello, I'm waiting. 20 here. How do you arrange? Third shell can put how many? Third shell can put how many? 8, right? And 2.8.8 point. Wait, simple maths there, wait. 2 plus 8 plus 8 plus what is 20? Yes, 2. Thank you. So please draw this yourself. Draw this yourself. This one a bit fussy. You have to draw 4 layers here. Okay, so where are the elements X, Y, Z located in the modern periodic tables of elements? Okay, where do you think X is? Which group, which period? Do you remember? Okay, let's talk about the group first. Group, we look at what? I mentioned this last week, one. Okay, how do you look at a group? We look at the valence electron. So this is group 13. Remember? So why is it not group 3? Like I said, group 3 to 12 we skip. Can I? 3 to 12 we skip. Valence electron 1, group 1. Valence electron 2, group 2. Valence electron 3, group 13. 4, 14, 5, 15, 6, 16, 7, 17, 8, 18. Can? So if I have 3 here, I'm group 13. I have 3 layers, 3 shells. That means I am period 3. Okay? I've done one. So can you please answer me this? What group is this? You know what group is this? Jenny, what group is this? What group is this? I have 7 valence electron. So what group? Which group? 17. Good. Period. How many layers here? How many shells here? 3. Good. So period 3. What about this? What about this? This is group. I have 2 valence electron. So I am group. Which group? We go 1, 2, 13, 14, 15, 16, 17, 18. So this is group 2. Good. Period 4. Good. Okay. So how do atoms achieve stable? So how X becomes stable? Donate 3. How Y becomes stable? Accept 1. Okay, Can I'm just gonna speed this along, Okay, so let's look at question 18. Okay, so you see, nuclear number. Okay, 1 plus 0, 1. 1 plus 1, 2. 1 plus 2, 3. 6 plus 6, 12. So this is 13, 14. You don't even need to calculate. You just look at the number here already. It's already here. Do you need me to repeat what is nuclear number? You don't, You have to keep asking this. Okay, so the use of isotope medicine, so many. Cobalt 60 for killing cancer cell. Sodium 24 to detect blood clot. Iodine 131 to detect thyroid problem. Agriculture, phosphorus 32 to determine the rate of absorption of phosphate fertilizer. Okay, so this one, I'm just going to give you the answer. Carbon 14 is for ancient artifact. See how old something is. Phosphorus 32 is for phosphate. Cobalt 60 is to kill cancer cell. Sodium 24 is to detect leaks in underground pipe. Okay, it is what it is. What you memorize just now just comes out like this. Okay, so let's do one more. Question 20. Okay, again, proton, electron, they should be both the same. Blue color ball, neutron is yellow color ball. Okay, so 12 plus, this one should be 12, because equal this should be 18. So what's the nuclear number? Nuclear number is proton plus neutron. So 6 plus 6, 12. 6 plus 7, 13. 12 plus 12, 24. 18, 17, 35. Okay, guys, I want you to answer me this. State a pair of isotopes. Which two of these they are isotopes? They're the same guy. They're the same IC number, just different yellow ball. Who's like this? We have PQRS here. Which two here is the same? Yes, very good. That's your P and Q. Okay, explain why. Why do you think it's P and Q? They have the same. Same what? Guys, same what? Same what? Anyone? They have the same what? same proton number, but different neutron number. Okay, two use of isotope, we mentioned it just now. This one you can go connect this yourself. Okay, guys, this chapter, we wrap it up. It's the end of chapter 8. Do you have any question? It seems like you guys are still a bit blur. Is it? Jenny, are you still blur? Are you or are you okay with this chapter? Make sure you watch my video a few more times if you want. All right, guys, this chapter is a must score in exam. Okay, it is very straightforward and the explanation, everything is very short. So there is no excuse for you not to score. Okay, so right, so I will assume you understand So guys, next week it will be the last class before we head for holiday So please come next week and we'll go for holiday in the following week. Okay, so I will see you next Wednesday. Okay, so take care. I'll see you soon. Bye bye.